Hi, students. We're going to cover the Boolean Expressions AP Classroom assignment. All right, so let's get started. So for number one, the question is, which of the following best describes the conditions under which the expression will evaluate to be true? So the easiest thing to do for this question is examine the possibilities of A and B together. So first what could happen is A and B are both true. So if A and B are both true, what do we get on the left and what do we get on the right? So if A and B are both true, and we'll write this beside the actual statement. So if A and B are both true, we're going to have true and a true or false statement. And so remember, for an or statement, we're going to get true if one of the statements is true. So on the left, we would get true. You know what? I'm going to write T or F for true or false to save a lot of time. So we would get true and true or false. And that's going to equal true and true. So remember, for an or statement, one statement has to be true. So we basically get true and true on the left equals, is that equal to true and true? So we get is true equal to true. And remember, double equals checks for primitives. Are they in the same location? Or if they have the exact same value? And in this case, that is true. So when A and B are true, we get a true statement. That evaluates to be true. So when A and B are both true, we get true. So now we could also have A is true and B is false. So if A is true and B is false, then we're going to get, so A is true, so we have true and so B is false, so we have false or false. So on the left, you're going to have a true statement and a false statement. Remember, that results in a false statement. And then we're checking if that equals false, true, or true and false. So hold on a moment. So that's going to give us true and false. I keep saying I'm just going to write a T and an F. So remember, true and false also going to be false. So and now we're checking, is false the same thing as false? And so that is going to also be a true statement. So if you see the expression false equals false, that's true because it's the same thing on both sides. So even though both statements are false, it is true that those false values equal each other. So when A is true and B is false, we get a true statement. And you're going to get the same thing if you switch A to be false and B is true. So far, it doesn't matter what happens. If A is false and B is true, we still get a true statement. And so the last thing is A and B are both false. So if A and B are both false, then we're going to get, let's take this out. So we're going to get false and so like this is a false and something else. And so we already know the left side of this statement is going to be false because the first part of the and statement is false. So it doesn't matter what this evaluates to be. And so then on the right side, we're going to have false and another false statement. And so we're going to get false on both sides. So we're going to get false double equals false, which is actually true. And so no matter what we choose for A and B, the expression is going to evaluate to be true. And so again, all we did was we used every possible combination of A and B. Either they're both true, either they're both false, or one is false and the other is true. And so that's just 4 combinations that sometimes you will have to go through. For number 2, we are examining De Morgan's law. So remember, De Morgan's law is the negation of one Boolean statement, and a second Boolean statement is not the first Boolean statement or not the second Boolean statement or expression, I'm sorry. And so that's the first De Morgan's law. And the second one is not A or B is not A and not B. And so for 2, we're just tracking. We're going to go through this step by step. So we have not, and we need to do the opposite of this statement, switch that to be and then do and negate that statement. So the negation of the not is going to give us A and B. And then this or changes to be and. So we get A and B, and we now need to do the negation of C or not D. So we have one more step. So the A and B is going to stay the same. So we still get A and B. We'll keep that in parentheses. And then we're going to get not C and D. And so that's going to mean that A is our answer. We don't have to go through the other options because just by working this out, we ended up with the correct answer first. For number 3, it's the same thing that we did on number 1. You want to choose A and B to be true, A to be true, B to be false, B to be true, A to be false, and A and B are both false, and see what happens. So we're going to say, we'll make a little note of what happens. So A is going to equal B, which equals true. And we're going to write what happens in statement 1. So in statement 1, you're going to have true and true. So that's going to be true. And then in statement 2, you would have false and false. And that's, of course, going to give you a false statement. So right now, when A and B have the same value, we get different things for 1 and 2. The second thing that could happen is that A is false and B is equal to true. So in that case, for statement 1, you're going to have false and true, which is going to be false. And then for statement 2, you're going to have true and false, which is also going to be false. So right now, when A and B are different, we get the same thing for 1 and 2. The next thing that we need to check is what happens if, so we can see that because A and B they could be interchangeable. If A was true and B was false, so if A is true and B is false, we're going to get the exact same thing. You're going to have true and false for statement 1, and that's going to be a false statement. And then for statement 2, you're going to have false and true, which is still a false statement. So right now, when A and B are different values, statement 1 and statement 2 give us the same thing. And the last thing that could happen is A and B are both false. And in that case, what's going to happen is the top statement is going to be false and false, which of course is false. And the second statement is going to be true and true, which is going to be a true statement. So if we look at our answer choices, we would select option D because the expression 1 and expression 2 are only going to be the same value, which is false, when A and B are different. So that means like when either statement A is true and statement B is false, or when statement A is false and statement B is true. Number 4, we have if A is less than B or C is not equal to D, do some stuff. And we want to choose the correct if else statement where it's logically equivalent. So we don't know anything about A, B, C, and D. So we can't hope that the truth, like the values turn out, like we can't hope that the values somehow could give us true and false and we can determine what happens. What we can do is negate, see which one of these if statements has the negation of what I'm underlining. So whatever is the negation of this statement, we're going to apply De Morgan's law to this, which that is logically equivalent to that. So what is not A is less than B or C is not equal to D? So remember, for De Morgan's law, you just negate the first term, switch the or to an and switch the second statement. So the opposite of A being less than B is A is going to be greater than or equal to B. Remember, the or turns into an and. I'm terrible at writing an ampersand, so I'm just writing and. And the negation of C not equaling D is going to be that C does equal D. So we're looking for an if statement that has that. And I think E is that option. So we have A is greater than B A is greater than or equal to B, and C is equal to D. All right. For number 5, so we have a Boolean B1 equals true and 17 remainder 3 equals 1. So remember, on the equal signs means that we are assigning B1 the truth value of true, and 17 remainder 3 is equal to 1. So 17 remainder 3 is actually 2. So the statement, so this is 2 equals 1, which of course is a false statement. So this simplifies to be true and false, which further simplifies to be just a false statement. So we're trying to assign B2 a value that's false because B1 is false. So now we just have to go through and see what happens for each one of our options. So for option A, we have false or whatever the truth value for this is. 17 remainder 3, which we already know is 2. So we're just going to cross that out and put 2. 2 equals 2 is true. So we have false or true. That evaluates to be true. So option A cannot work. For option B, we have false and some statement. It doesn't matter what the second statement is, a false and something else always evaluates to be false. So this is the option that we want because B1 was assigned a value of false. So 17 remainder 3, that is 2. So that statement is true. But remember, false and true gives you false. And so then it's going to have to be true that the rest of these statements report a value of true. And that's actually what happens. I'll leave it to you to check those. So, we can go through them. So 17 remainder 3 equals 1. That's false. But remember, true or false, that's true. For true or false, that's still going to be a true statement. So true and true is true. And true and false, that's a false statement, but false or true is going to give you true. For number 6, we have this if statement, and then inside the if statement, we have, so that's what, like, I think the if is missing, because when I see this on AP Classroom, I see a second if statement. I'm sorry. So here we should have, yeah, I'm looking at this if. So there should be this statement if false or true and false. I don't know why this didn't print. It's a PDF, so I didn't even think that it wouldn't print. So then we have this other condition. So what's the result of this code? It's actually going to turn out that it doesn't matter because we never get to it. So remember, if statements only work if the condition inside the parentheses is true, or if that Boolean expression turns out to be true. So remember, false and true is going to evaluate, this entire thing is going to evaluate to just be false. And then false or false is going to evaluate to be false. So this is logically equivalent to if false. And so if this statement is false, that's never going to happen. So if what's inside is false, that's never actually going to be true. So none of what I'm putting the brace around ever executes. So the only thing that's going to print is this second if statement, because true or so when you're evaluating this, the true and false, you have to evaluate first. And true and false, that's going to evaluate to be false. But true or false, that evaluates to be true. And so this is the same as if true. And so all that's going to print is third. None of the above code, none of the code with the brace is ever going to print, because the first if condition, the outer if condition is never reached. For number 7, we have we have int a equals 10 and int b equals 5 times 2, and we're printing the Boolean expression a double equals b. And so this is either true or false. So you're printing the result of 10 equals 10, and that's a true statement. So D is going to be correct. So this won't print 5, 10, 10 equals 10, or false. Number 8, we are assigning a Boolean value x the result of this logical statement. So 5 is less than 8. That is a false statement. So that statement is false, and 5 equals 8 is also a false statement. But false double equals false is a true statement. So 8 is going to give us a value of true. And again, that's because two false values, the only time you can get a true is if you're checking the equality of those two things. And the reason A, B, and C cannot work is because you cannot assign an int value to a Boolean, and E is incorrect because the statement is actually false. So for number 9, the last one is we have x is less than or equal to 10, double equals y is greater than 25. So the only time this statement is going to evaluate to be true is if the left side is true and the right side is true, or the left side is false and the right side is false. So we're just going to go through and substitute in the values of x and y and see what happens. So 8 less than or equal to 10, double equals 25 is greater than 25. So this statement is true, and 25 is greater than 25 is false. So false, true, double equals false is false. So A can't work. Then for B, so we'll write A here. And for B, we would have 10 is less than or equal to 10. And does that equal 10 being greater than 25? So you end up with true double equals false, which again is going to report a value of false. So B does not work. And for C, so we'll write C up here. So for C, we get 10 is less than or equal to 10. And does that equal 30 is greater than 25? So 10 less than or equal to 10, that's a true statement. And 30 greater than 25 is a true statement. So true equals true reports a value of true. So C is correct. And so if you go through and check D and E, you'll see that you get false. You'll get false on one side and true on the other side, which is going to make the statement false. If we gotten two falses, we would have gotten true. All right, so that concludes this video on Boolean